The reason why we're interested in SVGs is not because we're judging them as image models, but we are really judging them as coding models. Because the way we actually create those SVGs is we actually write code, or language models write code, so that way we can visually assess quickly whether the model has written good code or not.
That one wasn't even a bridge there.
Yeah, exactly.
I'm Joyce from LMArena, and today I'm here with Peter, AI Capability Lead. So why SVG and not any other image file format?
Yeah, so the strengths of SVG is that you can write 50 lines of code, maybe a few hundred lines of code, and then you create an image. And the images are nowhere near as good as what we'd get with actual image models. But what we want to try and get to kind of bridges the gap is that we can use code, which is a thing that language models are pretty good at, with the visual way how we can quickly assess whether the output is good or not. So that's why it became popular.
Is that the literal prompt? It's a very short prompt.
Yeah, you can put in a short prompt, and in this case we're looking at the Golden Gate Bridge, we are looking at the sea line and the bolt, so there are a few different elements that we want to introduce. So even creating a Golden Gate Bridge, you actually need to understand the geometry of it. It's quite a complex structure. So quite often in some of the generations what we're seeing is that it's completely out of shape, things are not connected, it doesn't remind you of the bridge sometimes. So the quality can really vary, and that way we can really work out and see at a glance which model understands how to create one and not. What we're really looking for is how does the model interpret this prompt, and then precisely what geometrical shapes it decides to put into the code, to define through code, so then the image overall makes sense. And you can see in some of these generations that the complexity of some of them is a lot higher. We see gradients sometimes in the background, we see much more complicated shapes which are sticking together nicely, versus for much worse generations you just see some blobs and circles. You can really see that the top ranking model and the bottom ranking model, you can just see the bottom ranking one just doesn't make any sense. You can barely work out what the prompt would have even been. And all of it is just a quick way for us to really assess the quality of the code. A popular way to test these models became to type in a simple prompt of a pelican on a bike. And through that simple prompt, you can really quickly at a glance see how well the different models generate these SVGs. It's an unusual image, and it's also not something that is straightforward to imagine how those two elements exist together. So this is an interesting way to just see at a glance how model deals with that. Something we should be careful with is that there is a way how labs could overtrain on SVGs to basically be able to particularly produce very high quality SVGs without necessarily being a good model. So every time we pick an easy benchmark like this, we need to be careful that the models are not over-indexing on just producing the pelican on the bikes or Golden Gate Bridges and so on. Because there is a way how they could just introduce more SVG data, they could introduce more preference data and reinforcement learning loops and so on to be only good at creating SVGs.
Yeah. So you're saying that model providers, now that they know that developers are using this quick and dirty way of measuring coding ability, they might over-index on SVG generation.
Yeah.
And it's a false proxy for how well it performs in code.
So if we look at the difference between the generations, even a few months apart, if we look at Opus 4.5 and the quality of generation there versus Opus 4.1, we can see pretty big difference. So the question is Opus 4.5 generally so much better at everything, and this is just happens to be a task that it nails as well, or are labs starting to train on SVG-like outputs a lot more to get the quality of SVG generations out?
What do you think?
I think we are starting to see labs to train on these a lot more, because the reality is no one needs high quality SVG generations. This is not a useful task at all.
the last time we talked about like how this correlated with like agentic workflows, specifically for coding. Can you just tell me a little bit more about that? And is this like a developer would then assess which coding model they're using with Cursor or something like that?
I would say this is where SVG falls down a bit, just because the agentic capabilities require more of an iterative approach, where you might want the model to work for 10 minutes or to go into different directions, to maybe go look at a bunch of code and evaluate different aspects of the application you're building. In SVG, just because of the nature of the code that it's writing, it's much more constrained. So I would say it's quite likely that the models that do particularly well on SVG, they're not necessarily good at agentic capability, and vice versa. These are not necessarily aligned. The beauty of the Arena is that we get whole spectrum of users with a whole spectrum of different prompts. So I would say that's the really good way of doing this. For a very quick test, if I just want to get a quick sense, is it at least in this bucket or that bucket, I think SVG-like tests are pretty good. They seem to correlate, at least for now, pretty well with their abilities more generally, but we should definitely be careful that we don't just do that, because there's a whole spectrum of different things we want models to do.